Hi, I'm Stephen Magill. I've been doing academic research in software analysis, security, and programming languages for more than 15 years, first as part of my PhD work at Carnegie Mellon, and then at other universities and industry research labs. And over the last few years, I've gotten more and more interested in the practice of software. So open source development practices, how enterprises approach software, how they use open source, and really how to best contribute to these communities by improving tools and practices. And so I'm going to be talking about some really cool research Gene and I have done in that space.
Awesome. My name is Gene Kim, and I've been studying high-performing technology organizations for 21 years. And one of the funnest projects I've gotten to work on is the State of DevOps report. And that was with, of course, Dr. Nicole Forsgren and Jez Humble. And this was a cross-population study that spanned over 36,000 respondents over 6 years. And it gave us a great glimpse of what high performance looks like and what are the behaviors that create high performance.
So, in this work, we're going to be looking at open source. We're going to be looking at usage of open source. And it's probably not a surprise to hear that almost everyone is using open source, right? Nat Friedman, CEO of GitHub, claims that 99% of new software projects include open source components. And so this means they inherit any open source vulnerabilities. So if you're out there and you're using open source, you want to be remediating those vulnerabilities as they arise. But even better, you'd like to stay ahead of that vulnerability curve and avoid being in this position of having to remediate. So how do you do that? You have to consider that when you use open source, you're not just importing some code, you're adding developers to your team, right? Those open source project contributors, they become contributors to your software. And this will help you. This increases agility, imports great security practices, or will it? Will it import great security practices, or is it going to be holding you back? Is it going to be a source of vulnerability, right? Like, what are these extra developers bringing to your team? And so that's what we dove into. What practices lead to good security outcomes, and what should you look for when you're choosing these open source components?
And by the way, Stephen and I were sitting in the GitHub Universe session. We heard Nat Friedman say that, and we're like, well, when you invite these developers into your house, are they going to actually help you build your kitchen, or are they going to trash your kitchen, right? And are there ways to tell? So I had mentioned the State of DevOps research, and it was such a fun study because it linked cultural aspects with technical practices and architecture. And so on the next slide, in terms of setup, when some friends reached out to me some years ago to talk about this potential research project and being able to look at the data from the Maven ecosystem, I jumped at the chance because it was a way to look at what update behaviors look like in the wild. So for those of you who don't know what Maven is to Java, what NPM is to JavaScript, what PyPy is to Python, Ruby is to Gems. And so on the next slide is someone who benefits so much from the Java ecosystem and Maven because my favorite programming language is Clojure. It was just an opportunity that was irresistible. And so when this came up and I looked at the data set that was available, being made available to us, I immediately reached out to my friend, Dr. Stephen Magill, and asked if he'd be willing to collaborate and jump into the data and see what we could learn.
And while I spend most of my time in the Haskell ecosystem, it certainly gives me an appreciation for functional languages and the role that Scala and Clojure play as these functional languages targeting the JVM. So super exciting to dive into this space and just see what we could find in this wealth of data. And the key questions that we asked were really twofold, some about the open source side and some about the enterprise side. On the open source side, we wanted to know, how do these projects manage their own supply chains? The nice thing about open source is all the dependencies, all those transitive dependencies, they're all open source as well. So you have a great amount of data that you can aggregate, label, do analysis on. And that was our focus in the first part of this work that we went and embarked on. And we wanted to look at not just summary statistics on like how many projects are out there, how many vulnerabilities, but really deeper analysis that describes the behavioral patterns we see and ultimately would lead to guidance and insight for people who consume open source. And then on the consumption side, we wanted to look at how do enterprises manage their open source supply chains? What governance tools and practices do they employ? And what impact does that have on security and productivity? And then in the course of looking at both sides, we actually observed some really interesting facts about the value of working together, having enterprises deeply involved in open source and really welcoming community contributions back into corporate open source projects as well. So as Gene said, this all started 2 years ago when we learned about this data, learned about what you could learn from looking at Maven Central data, looking at the Maven ecosystem. And that really led us to do this deep dive on update and security practices. And that turned into chapter 3 of the 2019 State of the Software Supply Chain report. We started that work in 2018, published the report in 2019. And we had such a great time with that research. We teamed up with Sonatype again to do further analysis for this year's report, the 2020 report. And this time in 2020, we focused on the consumer side of the equation, looking at how enterprises manage those supply chains. But first, we're going to dive into this 2019, summarize the 2019 results. And in that work, as we said, we looked at Maven Central. There's really an amazing amount of projects, of components, of data out there on Maven Central. 310,000 components, 4.2 million versions of those components, so individual jar files. Each has its own vulnerability history, its own dependency graph, its own API changes with each version, which can cause problems. Almost 7,000 of those also have associated GitHub repos, which gives us a whole other set of data that we can correlate against that includes metadata on team size, commit frequency. We can look at individual commits and the history of code changes. And then of these components, about 9% had a vulnerability associated with them. But then when you look at the dependency chain and those transitive dependencies, that increases to 47% of components have some sort of vulnerability that impacts them during the period when that component is the current version.